Hello all. Now we are starting with the concept of complexity, time complexity of insertion sort. That is how much time insertion sort is taking to sort the list of values in the increasing order. I say that first of all there are best case, worst case and average case. Best case says that the amount of resources that the program utilizes to deliver the result are minimum. In the algorithm, we normally take the resource as time. So we say that it is the time complexity in the best case, that is minimum time taken. Similarly, time complexity in the worst case, we say that it is the maximum time taken. Okay, this is the minimum time, and this worst case says that the time to generate the result is maximum. Fine. I say that what is the concept of insertion sort? I say that the value to be inserted, that each time the array is consisting of two portions. One is the sorted portion, one is the unsorted portion. The first value of the unsorted portion is inserted into the sorted portion. When this comparison, the comparisons that are this value, say for example the name of the value is x, when the number of comparisons that each of the value x encounters is minimum, then the best case scenario comes into picture. And when are the comparison minimum? I say that if the values are to be sorted in the increasing order, and this is the input. Values are to be sorted in increasing order, this is the input. We start the process of insertion from the second value. Second value, that is 10. It will be, this is a sorted portion because it is a single value. Single value is always sorted. So 10 will be compared with 5. When 10 will be compared with 5, 5 is greater, 5 is lesser, 10 is greater. So no shuffling will be happening. Only the variable will be shifting to the right. That is, now is the turn of 15 to get inserted. So what is the number of comparisons that 10 has encountered? Number of comparisons for 10 is only single comparison. That is with 5. Now what will happen with 15? When 15 is to be inserted in the sorted portion, this is the sorted list of values. 15 will be first compared with 10. Since 15 is greater than 10, so there will only be single comparison in this case also, because if it is greater than 10, it is guaranteed that it will be greater than 5 also, because this is a sorted portion, sorted in the increasing order. Similarly, what will happen with 20 now? Now this is my sorted array, that is 5, 10 and 15. This is the sorted portion, and 20 and 25, this is the unsorted portion. Now is the turn of 20 to get inserted. When 20 will get inserted, it will be compared with 15. Again 20 is greater than 15, so it will be greater than 5 and 10 also, so no comparison with these two values. Only a single comparison 20 will be encountered, so only one comparison. So I say that 20 has also got compared with only one value, that is 15, and it has got placed at the correct position. So now the first four values have got sorted, only 25 is left. Again the same case, that 25 will also be encountering only a single comparison. So how many comparisons have come into picture? That is 4. What is the array size of the array? That is 5. So it means if the array size is n, then the number of comparisons that come into picture is n minus 1. Why has n minus 1 come into picture? Because for 5, no comparison was there. Only the rest n minus 1 values, each of them encountered single comparison, making the total number of comparisons as n minus 1. Now what is the asymptotic notation of n minus 1? It is theta of n. It is theta of n. So we say, since it is a best case, so we say that the complexity in the best case scenario, that is represented by omega, that is n to the power 1. This is the time complexity of insertion sort in the best case scenario. Now come up with the worst case. Worst case is vice versa. Vice versa in the sense that if the result is required in the increasing order, if the result is required in the increasing order, my input is reverse. That is, input is in decreasing order. Input is in decreasing order. I require the result in the increasing order. This is the input. Now, how will the sorting be happening in the insertion sort? First is the turn of 20 to get inserted. Now 20 will be compared with 25. When 20 will be getting compared with 25, what will be happening? 20 will be shifted to the left. This is the position where 20 will get inserted, and 25 will be shifted to the right. The rest of the three values are lying as such. So how many comparisons did 20 encounter? This is the number of comparisons I am writing over here. How many comparisons did 20 encounter? Single comparison with 25. Now this is the sorted portion. This is the unsorted portion. Now is the turn of 15 to get inserted. When 15 will be getting inserted, it will be compared with 25. So since 25 is greater than 15, 25 will be shifted to the right. Then 15 will be compared with 20. 20 will also be shifted to the right. Now is the left hand, nothing to compare. So 15 will be inserted over here. So I say that this is the sorted portion now. This is the unsorted portion. How many comparisons did 15 encounter? It was compared with 25 also, 20 also. So it means 2 comparisons to 15 was compared twice. So 2 comparisons it encountered and got placed in the sorted sub-array. Now is the turn of which of the values? That is 10. How will the comparisons be executed for inserting 10 into the sorted portion? First with 25, then with 20, then with 15. Each of the 3 values will be shifted to the right, and then comes the leftmost position where 10 will get inserted. So it means 10 was compared with all the 3 values. So how many comparisons did 10 encounter? 3. Now in the same scenario it comes with the last value, that is 5. Sorted portion, the first value in the unsorted portion, that is 5. Since 5 is smaller